In this video, we will solve this coding question called toSum. So it is the easy level question, and this can be asked in any interview. Let's understand and let's see how we can solve this, and we'll also see how we can explain this to the interviewer. We'll see the approach how we'll explain. So here it says given an array of integers called nums and an integer target. So we have to return the return indices of two numbers such that they add up to a target. So here they have given an array called nums and an integer value called target, and the output should be such that we have to return the index of those numbers such that if we add those two numbers, the sum should be equal to this target value. So here it says you may assume that each input would have exactly one solution. So here only one answer will be there. In this input, whatever input they'll give, only one answer will be there. Like in the first input 2, 7. If you add both of them, it should be 9. So only one answer. So there are no other numbers that can sum up to 9. So here it also says that we can return the answer in any order. So it can be 0, 1 or 1, 0. The order can be anything. So one thing we have to keep in mind here, we have to read the question thoroughly and understand what is the input they have given and what is the output they are expecting, and what are the what are the basic cases that they are trying to convey, that we have to keep in mind. And after that we have to read these examples to understand the input better. So if you see the first example, there is an array nums. It has 2, 7, 11, 15 and a target 9 is given. If we see like 2, 7 adds up to 9. So we can return the index of 2 and 7, that is 0, 1, or it can be 1, 0. Here explanation also they have given. If you see the second example, here the array is 3, 2, 4, target is 6. So 3, 2 not equal to 6, 3, 4 not equal to 6, 2, 4 is equal to 6. So index of 2 and 4, 1, 2 or 2, 1 we can return. Similarly, if you see the third example, here an array with same element is given. So target is 6. So we can say like 0, 1. Here constraints also we have to keep in mind while writing our code. It says the length of the array can start from 2. So minimum 2 elements will be there, and it can go up to 10 power 4. And whatever elements in that array, they can be in between minus 10 power 9 to 10 power 9, and target value can be in between minus 10 power 9 to 10 power 9. Here they have highlighted like only one valid answer exists. This we should keep in mind, and we should write our code. So now let's see what all the approaches we can use for solving this. Before solving any problem, we have to see that what is the approach that is coming in your mind right now. Like, don't think of any time complexity or space complexity as of now. Just try to solve the problem in whatever way you can solve. So first what we'll do, we'll try to see how we can solve this. The basic logic will be, there is an array, we have to find the sum of the elements, like 2 elements. What I can do, right, I can iterate through this array, and while iterating, right, I can take the first element and I can try to add the numbers with each of these elements. Like, let's take this is the first half, this is the second half. So I'll take 2, I'll try to add with 7. 2 plus 7, 9. So I'll try to compare with target. Yes, it is equal. So I'll return the index of 2, 7. So in this example, it is coming in the initial iteration itself. Let's say this is not equal to the target, and target is some, I mean, target is like not in this position, it is in some other position. What we'll do, we'll go to 2 comma 11, 2 plus 11 and 2 plus 15, one iteration. And here again we'll come to 7, next iteration. 7 will compare with 11, sorry, we'll add with 11. We'll see if that, we'll check the target. If not, the target is not satisfied, we'll go with 715. Similarly, now third iteration 11, will add it with 15. So here if we observe, right, we are iterating once all the elements, like one for loop will be there. Okay, in the second in the next part, will in the inside, like we'll have to run through another loop. So basically two for loops will be there, nested ones. So if we see this approach, right, we will be able to solve this problem, but the thing is the time complexity will be big O of n square here. So we should see that what is the time complexity we have, and space complexity will be like big O of 1, because we are not using any extra space, we are using the same array. Time complexity is little bit, so it's bit higher. We should see that how we can optimize. So while explaining to the interviewer, right, you have to explain naive approach or brute force approach for the current problem, and you have to see the time complexity and space complexity. After that, you have to try to see how you can optimize the time complexity and space complexity. So for that, as we have seen the brute force approach, we'll try to see how we can optimize this one. Let's say big O of n square is the time. If you see here, right, here the follow-up can be, he has given like, can you come up with an algorithm that is less than big O of n square time complexity? So big O of n square is a very high time complexity, like it's taking a lot of, it will take a lot of time based on the input, right? If you see the constraint, the input can go up to 10 power 9 and length can go up to 10 power 4. So big O of n square is too huge. So we have definitely have to minimize the time complexity. So now we will see the optimized approach and we'll try to write the code for that. The optimized approach, simple, I can say, like if you find any question which has the pattern like given an array of integers, we have to return some pairs, or we have to return here, we have to return the pair of indexes of the element, like 0 comma 1, we are returning the pair. If you find this kind of questions, right, simple one thing you can keep in mind, you have to use the collections. It can be array list, it can be set, or it can be map. Okay, these things you have to keep in mind, and based on that try to build your logic, like what suits best for this solution, for this problem, and come up with a solution accordingly. The logic which I am trying to propose here, right, we will try to use an hash map here, and I'll try to explain like why we are using hash map. So what we'll do, right, initially hash map will be empty. Okay, hash map will be empty. What we will do, we will iterate once for all the elements. Okay, we'll check the hash map. Initially hash map will be empty. We'll take the first element and we'll check this first element 2 is already there in the hash map. Initially it is not there. So what I will do, I'll add to that element and that index of that element. Okay, next, in the second iteration 7. So here while comparing, right, we'll not compare with this element 2, we'll compare with 9 minus this element. 9 minus 2 is 7. 7 will compare in the hash map if it is there. If it's not there, we will add this element and the index. No, 7 we have. So now 9 minus 7 we will do 2. So 9 minus 7 is 2. We'll check in the hash map if 2 is present. Yes, 2 is present. So what we'll do, we'll take this index and we'll take the current index of the element. Both of them will return as a array. So what we'll do, we'll return 1 comma 0 or 0 comma 1. So anything you can return. So the logic will go like that. Simple. We'll write the code here. As you can see, it has asked to return an array. So what we'll do, we will declare an array, and the size we know only one pair exists, so size will be 2. Let's say result array equal to, I'll try to initialize this. So I have declared an array called result array. Now what I have to do, right? I have to declare an hash map also. So let's say I'll take a map with integer and integer as key and value. New hash map. And now what I'll do, right? I'll try to iterate, like one loop we need, right, for iterating to all of these elements. So what I'll do, I'll try to add a loop int I equal to 0, I less than nums dot length. So we have to iterate through all of those elements till its length I plus plus. Now what we'll do, right, and we are comparing with this 9 minus these values, right? Let's take some complement variable. We'll try to do target minus nums of I. Okay, whatever value at that current index, we'll try to do minus with that. Now we'll try to check in the hash map if hash map dot contains key of what, this minus value whatever we have got complement. If it contains key, what we will do, this result array we have, right, result array of 0 equal to I and result array of 1 equal to what we will get here, result array of 1. So what we'll do hash map dot get of this comp value. Okay, right, yes. Now else, let's say it is not there in the hash map, so we'll try to add hash map dot put. What will add, will add that current element and its index, right, and at last we'll return the result array. So let us verify our code. So what we have done, we have declared a result array hash map. We are iterating through this loop, and this value we are storing in some variable, target minus this value, target minus this, target minus this, target minus this. So during that iteration we'll get that value. In hash map we are checking first hash map dot contains key. If this key is present, what we are doing, result of 0 is that index, result of 1 is that whatever the index at that key. Okay, hash map dot get of this one. If it is not there, hash map dot put of, we're adding the current element and its index to the hash map, and finally we're returning the result array. So let's try to run our code. Yes, it is accepted. Now let's try to submit. So if we see here, yes, it successfully got submitted. And if you go to details, you can see all the test cases passed, and memory is little bit high. We can optimize that. So what we have to do to optimize that, right now, like it is not needed if you solve it in big O of n times. So time complexity is here, like time complexity, what is the time complexity here? Only one for loop we are using, there is no other loop here. So big O of n is the time complexity, and space complexity, we're using an extra space. So big O of n, big O of n is a space complexity. So if you explain this thing for any problem, I think that should be more than enough, and that should be good. And I hope you like this video, and please share with your friends and subscribe to my channel. Thank you.